Hello, everybody. Today, what we're going to be talking about is standard deviation. To begin, what I kind of want to talk about is just what standard deviation is as a whole. All it is it's a number, and it describes the dispersion of data in comparison to the mean. So, as a good example, if you are sitting in your class, let's say you just took a test and your teacher told you what the class average was. How you determine the standard deviation is a way of comparing how spread out is all of that data. So, for example, if let's say the class average was 60%, but the standard deviation is 10%, that's talking about your dispersion of data. How different is everyone's marks in comparison to each other and comparison to the mean? So, if you had a standard deviation, let's say, of 20% versus 10%, that standard deviation of 20% would mean that there was a more wider range of data when it came to that exam. So if the average was 65, you had some people that were very, very below 65, some people that were very, very, I guess, a lot larger than 65. If you have a standard deviation of 10, then that is talking about a smaller spread of data. So there's people that got a little bit below 65%, higher than 65%, but there's just not quite as big of a range. So this video is going to show you how to calculate standard deviation by hand. I'm going to pre-warn you, it's a lot of work to do it by hand. It's not that the math itself is difficult. A lot of the operations that we're going to be doing are quite straightforward. It's the steps that that are involved in it can be quite confusing and quite complex and hard to remember. I think just looking at the formula is the hardest part of this. So let's get started. All right, so what we have here is I've just kind of written out the definition and I've tried to explain what the formula for standard deviation looks like. So starting with a definition here, we've got a measure of the dispersion or scatter of data in relation to the mean. The larger the standard deviation, the more spread out the data is from the mean. So I'm going to be using S.D to represent the standard deviation. So here's what we have. Here's the formula for it. It looks a little bit confusing, so let's kind of break it down into what all of these things mean. So here, this symbol is the lowercase sigma. It's a Greek symbol, and it tends to stand for standard deviation. So uppercase sigma stands for summation. In other words, adding. You're going to add a bunch of stuff together. X minus X bar. So this X bar represents the mean or the average of the data. You may also, depending on maybe what textbook you're using or what course you're talking about, they may also use this Greek symbol called mu to represent the mean. So it may look like mu. It may also be an X with the bar over top. N in this case is going to be the total number of data points that we have. All right, so breaking this down, this is the hard part of calculating it by hand. I mean, the math here isn't that difficult. We're subtracting, we're adding, we're square rooting, we're dividing. It's very straightforward. However, the hard part of this is kind of how do we get this to work? So let's go right into an example. So calculate the standard deviation of the following data using the following formula. So we have 5 students, we have 5 of their test scores. We want to figure out what would the standard deviation of this exam be. So what I've done is kind of broken this into a table so that we're able to really look at each section of this formula. First, what we need to figure out is what is X bar? What is the mean? What is the average of this exam? How we're going to do that is we're going to add all of these test scores up and we're going to divide by how many test scores there are. So let's do that. If you got a calculator handy, please put this in. We're going to add all those test scores together. We get 315. And we're going to divide by how many tests there were, which was 5. So overall, our mean is 63%. So if this was an exam and we had 5 kids take this exam, or 5, not even kids, just 5 students, and we divide by 5, the class average is 63%. All right, the next part of this formula is the X minus X bar. What this is saying is that we're going to take every individual test score and we're going to subtract away the mean or the average. If you get a positive or a negative number, you're going to keep it. It's all good. So for this first one, what that looks like, this student got 60% and the average is 63. So they have minus 3 as the X minus X bar. Next, we'll look at 71 minus 63. And again, we're just going to kind of do this all the way down. So here we have 8. All right, so what you're doing for this part of the formula is that you're taking each individual score and you're subtracting off the average. Next, what we have to do with this part is we have to square everything. All right, well, we're going to take our answers from before and we're going to square them. What we should notice here is that when we're doing this, that we should be getting all positive answers here. Here's where you got to be really careful if you're putting this into a calculator. Depending on which one you're using, if you do not put brackets around this, you're going to get a negative answer. However, what we know is that when I square a negative number, it should always be positive. A negative times a negative is positive. All of these numbers in this column will always be positive. Or I guess maybe not the biggest, but the most common mistake happens in this very step when you're going to calculate by hand. All right, next thing that we got to do, we have to take all of these values squared and we need to take the sum. So this again is talking about the sum, meaning that we are adding all of these things together. So we're going to add the 9, the 64, the 64, the 16, and the 1 all together. And we get 154. All right, so what we've done now is this top part of the formula. We need to now deal with the rest of it. So we're going to take this answer and we're going to divide it by the number of people that were taking that test. Well, n in this case is how many students were you talking about? N in this case is equal to 5. So we're going to take our answer from the previous part and we're going to divide it by 5. What we get there as an answer is 30.8. Perfect. Last step we got to do is take the square root of this whole thing. So let's take the square root of that number. And we get 5.549. There's a couple decimal places after that. I'm just going to put some dots. And that's how you calculate standard deviation by hand. I hope this helps you. Please let me know if you have any questions. Thanks.